So we are back to 1.3, and this is 1.3 part 2. And what we talked about in the first part is we were talking about equations in the form y equals mx plus b, right, which we called slope-intercept form. And that is the most workable form that we use when it comes to linear equations, things in slope-intercept form. So it seems to be the form that we're always trying to get to, right? And the reason we called it slope-intercept form is because m is our slope and b is our y-intercept, right? The other thing we talked about was, well, how do we find a slope given 2 points? And if you remember, if we had 2 points, x1, y1, and x2, y2, we could find the slope with the formula m equals y2 minus y1 over, weird, over x2 minus x1. And dang, sorry. And we use that, we could find the slope of any line given 2 points, right? And today we're just taking that a little step further. And what we're going to do is we're going to use formulas to get into slope-intercept form from 2 points. Sometimes let's forget the sometimes. The formula that we'll use to do that is what we call the point-slope formula. Now, if the slope-intercept formula has a slope and an intercept, the point-slope formula has a point and a slope, right? And I like to think of it as a series. So if I'm given 2 points, there's a process that I would follow to write the equation of a line. So if I'm writing the equation of a line given 2 points, and we want it in slope-intercept form, the first thing that I'm going to do is I'm going to use the 2 points to find slope, right? So I'm going to take the 2 points and I'm going to put them in the m equals y squared minus y1 minus y2 over x2 minus x1 to find the slope of that line. The next thing I'm going to do is I'm going to take the outcome of that and I'm going to plug it into what we call the point slope formula. Let's go. Use slope and 1 point, one given point, and I'm going to show you how to do all this. And plug into point slope form. When you simplify the point slope formula, it gives you slope intercept. So simplify to slope intercept. Now, if you're given anything in any of these spots, you just start where you are, right? Like say you already have a slope and a point, we'll just go ahead and plug it into the point slope formula. The point slope formula is y minus y1 equals m times the quantity x minus x1. And we're going to show you how that works. I'm going to take you through the process given 2 points. Actually, I'm going to start you, before starting you with 2 points, what if we're just given an m equals 2 and a point that we'll call, I'm making this up, right? I don't have notes here telling me what to do. I'm just making up a point, and I made up a slope, right? I have a slope of 2, and I have a point that I know is on that line. And once I know that, I can plug it right into this point slope form. Now keep in mind, this y and this x, they're our standard. We're not plugging anything in for those. What we're plugging in is our point at x1, y1. So I would have y minus y1. Well, our y1 is just 1 equals m, our m is 2, times x minus x1. Well, our x1 is negative 1. So I'm going to write it as a double negative. The reason I write it that way is it reminds me to connect it and make it a positive. Right? Negative, negative equals a positive. And now all I have to do is solve this for y, and it's in slope-intercept form, which is the goal we're trying to get to, right? So I'm going to go y minus 1 and deal with this distribution first. 2 times x is 2x. 2 times 1 is plus 2. I'm almost done, but I still have this negative 1 on the y, and we're trying to get that y all by itself. So we're going to go ahead and add 1 to both sides and then rewrite it as y equals 2x plus 3. This is the equation of a line with a slope of 2 that goes through the point negative 3, 1. And you won't always be given the slope. Sometimes you'll be given 2 points. You have to find the slope, and then you pick a point. And that will be what our next example looks like. So this is given a slope and a point. Our next one's going to get a little harder, right? What if I'm given just 2 points? What if I have the point so given 2 points, let's go with one that's going to work. 0, 4, and 1, negative 1. Write an equation in slope-intercept form. And if you remember, that's y equals mx plus b form, right? Where do I start with this? I'm given 2 points. So the first thing I want to do with those 2 points is find my slope, right? The formula for finding that slope is m equals y2 minus y1 over x2 minus x1. And so we'll just call this x1, y1, and we'll call this x2, y2. It's arbitrary. I could have picked whatever one I wanted for my 1 or my 2. So I'm going to go negative 1 minus 4 over 1 minus 0. Right? All I did was plug those numbers in. Here I've got minus 1 minus 4. Well, that's negative 5 over 1 minus 0, which is 1, which just gives me a slope of negative 5, right? So my next step that I need is I need to use that point slope formula to find the equation of the line that we're looking for. Well, we have our slope. Our point, like here we were given a slope and a point. Here we found our slope and we have 2 points. Does it matter which point I choose? No. Because both of those points we already know are on the line, so both of them will give us a similar equation, right? So I'm going to pick the one with the 0 in it. The reason I'm going to pick the one with the 0 in it is because anytime you have a 0, the math is easier, right? So if you ever can choose a point that has a 0 in it, pick the one that has the 0. So we're going to use our point slope formula, which is y minus y1 equals m times the quantity x minus x1. And we are going to use our 0, 4 point. So here I'm going to have y minus 4 equals our slope, which is negative 5, times the quantity x minus x1, while our x1 is just 0. And so when we go to solve that, we're going to keep our y minus 4 the same, but we're solving for y. And I'm going to distribute. Negative 5 times x is negative 5x. Negative 5 times 0 is just 0, so I'm just going to leave it like this for right now. And the only thing I have left to do is to move this 4 off the y, and I apologize that those both look like y's or both look like 4's, but one of them is a 4, I promise. And we're going to add 4 to both sides. And I'm going to get y equals, I can't combine these together, right? One's an x and one doesn't have an x, but I can write it as minus 5x plus 4. This is the equation of our line, right? It is written in slope-intercept form. It is glorious because I can graph this very easily given this information, right? Because what do I know? I know I have a point. This way because my slope's going to be negative. Who knows where we're going with that? But what do I know about this? I know that I have a point at 4 on the y-axis because it is my y-intercept. I have a slope of negative 5. That is the same as saying negative 5 over 1, right? It means I can take my up or down 5 and my side-by-side 1. One of them has to go in the negative direction, but only one of them can go in the negative direction, right? I can pick either one I want, but if I take both of them in the negative direction, right? If I make both of them negative, well, a negative over a negative is a positive, and your slope's going to go up instead of down. So it doesn't matter whether you use the numerator or the denominator negative, but you can only use one and you must use one. Does that make sense? So from this, I can count down 1, 2, 3, 4, and we'll call this 5. And I can then go positive 1 and put a point right here, and then I can graph that line. And normally I would make that line go through that point, but sometimes you miss. So that is the glory of slope-intercept form. And you will be given problems in both circumstances where you'll either be given 2 points or you'll be given a point and a slope, and you've got to get yourself there. And I'm sure all of you have done this stuff before. This isn't super new information. You guys did it in Algebra 1, but you haven't taken Algebra 1 or Algebra 2 for a while. Well, you took Algebra 2 last year, but let's face it, nobody remembers last year. The last thing we need to talk about is parallel and perpendicular. Does anyone remember what the difference between a parallel and a perpendicular line is? No one's super anxious. It's very good, right? One crosses, one does not. Parallel lines never touch, right? They are the same distance apart forever and ever and ever, right? And I think you've seen them. They kind of go like this, right? And they will never cross, no matter what. Perpendicular lines cross at a right angle. Right? So you'll see them sometimes written like this. Usually the symbol for perpendicular is like that. Right? Just that upside down T is usually the symbol for perpendicular lines. Now, perpendicular lines and parallel lines have something in common, right? If two lines have the same slope, they are parallel. So if I have y equals 3x plus 2, and I have the line y equals 3x minus 17,004, those two lines are parallel. Does not matter, right? As long as they have the same slope, those two lines will never touch. Right? If two lines have opposite reciprocal slopes, and I'll explain that. Reciprocal slopes, then they are perpendicular. So if I have a slope that is y equals 2/3 x plus 1, right? If I have a line with that, and then I have another line that is y equals negative, if this is positive and I'm going to have a perpendicular, the other slope better be negative, right? If my slope on one line is negative, the other one better be positive. Reciprocal means flipped fraction, right? So if I have minus 3/2 x plus 12, these would be perpendicular lines, right? So if L1 equals that and L2 equals this, these are perpendicular lines. Perp. Sometimes it won't be written in the fraction form, right? What if I have L1 equals, I should write it like this, like the dots, because I'm using equals with the y. Y equals 2x minus 4/3, right? So my slope on this one is 2. To have a perpendicular slope, I'm going to have y equals negative 1/2 x minus whatever, right? It doesn't matter what number's on the end. All that matters is our slope when we're talking about perpendicular and parallel. Right? These would still be parallel lines. Keep that in mind, because sometimes people see the whole number and they forget that there's a 1 under that number. So you want an opposite sign, flipped fraction, right? The only thing you're going to get in terms of asking if they're parallel or perpendicular is that you'll be given two lines and you just have to check the slopes. Keep in mind, they're going to ask you, is it parallel, is it perpendicular, or is it neither, right? Those will be your three choices, but they might not always write it in the slope-intercept form. You might have to put it in that form yourself, right? So if I made up, say I have line 1 equals, let's just try y equals 2/3 x plus 1, right? What if my line 2 was 2x plus 3y equals 7, right? I'm going to have to solve this whole thing for y to find out if my slope is good, right? What am I going to do? I'm going to start by subtracting 2x. Minus 2x minus 2x, and I'm going to have 3y equals minus 2x plus 7. And then I'm going to divide by 3. So I'm going to divide this by 3. I'm going to divide this by 3. I'm going to divide that by 3. And here I would have y equals negative 2/3 x plus 7/3. Now I want you to look at this and tell me, are these perpendicular? Our line 1 is 2/3 x. Our line 2 is negative 2/3 x. Do I have perpendicular lines? Do I have parallel lines, or do I have neither? Neither. According to, does anyone disagree with Anthony? Well, you shouldn't if you do, because he's right. Even though we have 2/3 on each of those, and one is negative and one is positive, my negative isn't a reciprocal, right? That fraction didn't flip, just the sign changed. So it would not be perpendicular or parallel. That is as tough as it's going to get in terms of your homework. I did a delta math. There's a couple that you'll have to graph, but they're pretty easy. They're all like slope-intercept graphs. Some of them are going to ask you, given a slope. So they're going to give you like a point and a slope and ask you to find the next 3 points. So say I give you the point 1, negative 3, and I know that we have a slope of 2, right? Let's call it m equals 2, or m equals 1/2, or whatever, right? What we know about this, when I have a slope of 2, it's 2/1. This is my up-down. This is my side-to-side, right? So if you think about this bottom is my x, this is my y. So every y is going to go up 2 and, well, up 2, and then, so we're going to add 2 to every y, right? And we're going to add 1 to every x. Does that make some sense? So I can find my next point just looking at this, knowing the slope, right? My next point would be 2, negative 1. If I did it again and I wanted to find the next point, I would just add 1 to this, and I'd have 3, and I'd add 2 to this, and I'd have 1. If I wanted to find the next point, I'd add 1, and I'd have 4, and I'd add 2 here, and I'd have 3. Does that make some sense? You can use your slope to find the next 3 points. So I think that's the only thing that we didn't go over that I know is in the assignment. You'll have a couple where you get a slope and a point. You have to find the next 3 points. You'll have a couple where you're given 2 lines and you have to determine whether they're parallel or perpendicular. And then you'll have a couple where you have to write the equation of the line given 2 points or given a point and a slope. That's all there really is to it. I didn't throw in any word problems, so it's all pretty straightforward. Does anyone have any questions about any of it?
And then there's going to be a second one on Thursday, Friday.
There'll be another assignment, another lesson on Friday. It won't be part of 1.3, but yeah. Well, if there are no questions, I am going to let you go early.